Daniel, and if you are new to this channel, on a weekly basis we shoot educational videos that will help you pass your exams with ease. So we encourage you to subscribe to this channel if you are yet to do so, and if you are subscribed, we also encourage you to share this opportunity with your friends and your family who will be writing similar exams just as you are. So without much being said, let's get started with today's class. In today's class, we're looking at electric field, a topic under physics. And under this topic, we are going to discuss the following subheadings: electric field, Coulomb's law, electric lines of forces, electric field intensity, and we'll prove down some formulas. We will not be able to cover all it takes in electric field in just a single class. So this class will be split into parts. I encourage you to watch the other parts which will be released as the week goes on. Please do well to subscribe and like my video. Let's get to this class. So the first subheading, electric field. What is an electric field? An electric field is a region of space where a charged body experiences an electric force. Alright? There are two types of charges in electricity. We have the positive charge and the negative charge. Whichever one of them, wherever you place them and they experience an electric force, that tends to be an electric field. Alright? So what does Coulomb's law state? Coulomb's law is a law in physics founded by French physicist Charles Coulomb in the year 1785. He stated that the electric force between 2 point charges Q1 and Q2, separated by a distance r, is directly proportional to the product of the charges and inversely proportional to the square of the distance between their separation. If I write this mathematically, I'll write it as the electric force F varies directly as what? The product of Q1, Q2 over what? R squared. Where force is the electric force measured in newtons. F is the electric force measured in what? Newton. Q1 and Q2 represent the 2 point charges measured in coulombs. While R here is the distance separating these two charges measured in meters. Alright? So if I will properly state this law, I will state it as what? The electric force existing between 2 point charges Q1 and Q2 is directly proportional to the product of the charges and inversely proportional to the square of the distance between their separation. If I will continue, we will introduce a constant K where F equals to what? K Q1 Q2 over R squared. Remember, F is the force measured in what? Newtons. K is the constant of proportionality. Alright, I will go further to state that Q1 and Q2 are the point charges that, like I've said earlier, and R squared is the distance between the separation. So K, which is the what? Let's call this equation 1. K, which is what? The constant of proportionality, has the value to be what? 1 over 4 pi to the E naught. Where E naught is also a constant known as what? Permittivity of free space. Now the value of K is given as what? 9.0 times 10 to the power of 9 Newton meter square per coulomb square. Alright? K is a constant and this is the value of the constant. Okay? Now, Charles Coulomb went further to explain that the forces of attraction existing between these two, the electrical forces existing between these two charges are of two kinds. It's either a force of attraction or a force of repulsion. There will be a force of attraction when the two charges are of what? Different nature. When they are not alike. Alright? When there's a positive and a negative, there will be a force of what? Attraction. But when there's a positive and a positive, there will be a force of what? Repulsion. And when there's a negative and a negative, there will also be a what? A force of what? Repulsion. So please take note of that. Alright? So as we continue, let us look at electric lines of forces. What are electric lines of forces? Electric lines of forces are isolated pathways where an electric charge will tend to flow when placed in an electric field. Alright? Electric lines of forces have properties, of which I will just name a few of them so that we can proceed to electric field intensity. So what are the few of them? 1. Electric field lines do not meet. That means they do not intersect or bisect each other. They will not cross themselves. Alright? Another property is that for a uniform field, the electric field lines are parallel, straight, and uniformly spaced. Another property again is that electric field lines are continuous at any point. Alright? Without further ado, let us go to electric field intensity. Now, what is electric field intensity? Another name for electric field intensity is the strength of an electric field. Mathematically, electric field intensity is represented with the letter E and is given by the formula F over Q. F divided by Q. If I would define it properly, I will say that the electric field intensity of an electric field at the point is the electric force per unit charge. Alright? This force here is the electric force, while the Q is the charge measured in what? Coulombs. Alright? So now, from our equation 1, now if I cross multiply, now I can call this, let's call this equation 2. If I cross multiply this times this, that means that my EQ equals what? F. Which I can say F is equals to what? EQ. I can call this equation 3. That means another formula for calculating the force of attraction between 2 point charges can also be given by this formula. Electric field intensity times Q. Alright? Now from equation 2, if I would bring equation 2 down, E is equals to what? F over what? Q. Alright? Now remember that in equation 1, the value for our F is equal to this. So if I replace this value for F here, that means my E will be equals to what? K Q1 Q2 over R squared divided by what? Q. When I replace equation 1 into this equation here, alright, that further applies that E will be equals to what? K Q1 Q2 over R squared times 1 over Q. Alright, when I introduce the multiplication inverse, the sign will change. That means my Q, one Q here will cancel on the Q here. Then my E will be equals to what? K Q over what? R squared. Please take note, here is what? R squared. Alright, I can call this equation 4. Now remember that we say the value of K is equals to what? 1 over 4 pi to the E naught. So if I introduce that value here, then my E is equals to what? 1 over 4 pi to the E naught times what? Q over what? R squared. Because this is the value of what? K. And I'm replacing it with this value because we said K is a constant that is equal to this. So if I do that now, that means my E equals to what? Q over what? 4 pi to the E naught, 4 pi R squared to the E naught. We call this equation 5. So in today's class, we'll be able to prove out how many formulas. We'll be able to bring out the first formula to calculate the force of attraction between 2 point charges called equation 1. Equation 2, the formula for calculating the electric field intensity or the strength of an electric field. Then equation 3 is another formula that can find the electric force between 2 point charges when you are given the electric field intensity and just a charge. We also went further to prove another formula for electric field intensity, alright, which is stated here clearly. So please, students, take note of this in your exams. The examiners may want to trick you, they may want to twist the questions and bring questions such that it is this formula you are required to use. Alright? And before you are able to use this formula, you must have known how to prove it. And that is the reason why we have taken our time here in this academy to break down this formula for you. This class, electric field intensity, cannot be conjoined in just a single class. So please prepare for the comment section this weekend. Alright, stay tuned as you stay with us, and please like this video, do well to subscribe, and tell your friends about this opportunity that you have just gained at this very moment. Thank you for staying with me to the very end of this class. I really appreciate you, and if there are questions, please do well to drop them in the comment section, and I'll be there to answer them one after the other. Thank you very much. May you remain blessed.